Good day, everyone. My name is Mobolurin Adekanmbi, Bo for short. I am 14 years old, and I'll be your teacher in this introductory class to Python for Kids. I consider it a great privilege to teach this class. I would like to give a special thank you to Data Science Nigeria for the opportunity to take this class and contribute to the vision of raising 1 million AI talents in 10 years. I am so excited that Nigeria will have as much as 1 million AI talents in 10 years, including myself. This will make us one of the greatest nations in technology. Aren't you excited? DSN is very interested in you and I. They want many kids and teens to understand AI very early before university. This is why they run many courses like this. 1. Bootcamps, summer schools, online classes, content and writing of AI books, such as the first AI book for primary and secondary school. In this picture, DSN distributed their book free of charge to kickstart the journey of artificial intelligence for many individuals. This course is largely associated with Beginner's Artificial Intelligence and Python Programming book for primary and secondary schools released by Data Science Nigeria. All my exercises are from the book. This book is the perfect hands-on guide to learning AI and Python without even the slightest experience. You can visit the link to purchase the book from Jumia and have it delivered to you anywhere in Nigeria. These are more from the book. These are links to also get the book. You can have it on Amazon Kindle, Amazon Paperback, Apple iBook, Google Play, and Jumia. Data Science Nigeria also has its very own hub, AI Hub, where amazing classes are run every day of the week, a large portion of them being 100% free. And if you are not interested in learning in large groups, you can also visit any other time of the day for personal study, with there are more than enough materials via books, videos, PDFs, etc. DSN loves as many children in primary and junior secondary school to learn AI. That is why it hosts many free AI summer schools like this one. These are some examples of the AI summer school. This is an example of their free machine learning course for pre-university students. It is such a nice class to learn AI before university. These are some examples of their last year's pre-university machine learning class. If you want to know more about DSN, you can go to the link on the slide for their achievements and annual reports. And if you want to further contact DSN, you can reach them via their number, their email, and social media platforms where they regularly post information on their future trainings, etc. With all that being said, let me properly introduce myself. My name is Mobolurin Adekanmbi, and I feel heavily privileged to have attended DSN's first AI Bootcamp, which has really helped me. To grow in AI, it requires attending bootcamps and learning extensively, and I consider myself a young and growing data scientist doing just that. You also learn more by teaching others. I was opportune to serve as an assistant teacher in the last year's AI summer camp for primary school. My job was to help the students follow the code writing. If they had errors, I'd review it, and also to get them to install Python properly. I enjoy seeing others learn because in the process, I learn as well. I have also volunteered as a part of the DSN team that was sent to various public schools to donate free copies of their AI book, which I cannot stress enough as an excellent guide worth reading. I must stress that mathematics is very important for data science. I complement my programming with my love for mathematics as an active mathematician. AI and other jobs that will be taking over the future largely do with a rich heritage in mathematics. I participated in the 2019 edition of Cowbellpedia Mathematics Competition, where I came 9th in Lagos and still actively practice and refine my math skills. I also learned by practicing with real-life business data to sharpen my skills on the global cargo platform. I am learning day by day to get better as I learn from the best of the world. I am currently in the top 8% out of 17,900 plus data scientists all over the world nearly 18,000 people from all different regions who are participating in the Titanic survival competition using logistic regression. I've also participated in many other competitions and hope to do more, as it allows me to learn more, master my mistakes, and learn many ways to do things better. I will encourage you to join Kaggle as soon as you start your journey into data science, machine learning, and artificial intelligence. The earlier, the better. I have been opportune to learn from so many experts who continue to help me grow. I am an alumnus of the Absolute Academy USACO Bootcamp, where I learned C++ and sharpened my Olympiad mathematics and computer science skills. It is important to attend relevant bootcamps to groom yourself and get better by the day. I am still learning and growing as a young enthusiast. Let me summarize my little experience in the world of technology. I code at mastery levels in both Python and C++. I've developed apps using Xcode Swift. I make 3D and 2D models using SketchUp and Photoshop. I make video presentations and cartoon animations with After Effects and Crazy Talk Animator 3, and also have a very rich history in game development using Unreal Engine and Stencyl. So with all that being said, let us get to class. Let us start with the basic question that many of us must have. What is programming? Is it about attending a program? What is it? Or you have probably heard something like programming is hacking another person's computer. That is wrong. It is much more than this. Let me attempt some definitions. Programming is the process of designing and building a computer program that does a specific task. Basically, you give your laptop some instructions and then it gives you the output. It is like the series of steps to cook a wonderful meal. Or in the most basic terms, it is a list of instructions that is executed by a computer to accomplish a particular task. Creating one of those instructions is programming and thus makes you a programmer. Let us look at an example of giving the computer some set of instructions in the form of programming. See the picture above, a turtle that wants to cross the road. This is an example of some instructions where for the turtle to cross the road, it will have to check if there are no cars or not. And if there are, it waits. And if not, it crosses the road. You can see the possible outcomes of true or false. So why do we program? Of course, we program to solve problems. For example, I want to know how many people are in a picture with thousands of people in it. Of course, you cannot count the number of people by yourselves. It will take way too much time. I want a car to recognize people automatically and stop for them. This will save millions of lives. A farmer wants to separate rice from stones and make his everyday work easier. A doctor wants to predict if someone has COVID-19 and not just a common cold or flu. We need a computer to simplify this task for us, but there is an issue. Computers do not understand our language. The computer only understands binary, which is a sequence of only ones and zeros. So I need something that translates our general language to the language that computers understand. That is a programming language. It enables us to convert our human instructions to the computer language of binary, which the computer understands and can then use the instructions to solve the problem. So in summary, the set of instructions are known as programs. Computer programs tell the computer what it should do, and these sets of instructions have to be instructed by the user. There are roughly 6,500 languages all over the world, and many of us can only speak 2 or 3. I've heard of polyglots who speak up to 10 languages, but we do not need someone who can speak that many languages if they do not have the ability to talk to computers in the same way some zoologists can speak to animals. The computer is also a polyglot. It is multilingual. It can understand many languages called programming languages. Some examples of programming languages are Python, Java, Swift, and C++. But in this course, we'll be working with only one language, Python. So why is a computer language called Python? We know Python as a snake. We also know the cobra, the serpent, the black mamba, and so many others. Was it named Python to scale or to appear scary and difficult to learn? No, of course not. Python is fun. Why, you may ask? It was actually named after a funny English comedy group in a television show called Monty Python's Flying Circus, which was thriving back in its day. So Python and comedy, here we come. So we can see that the creator of Python wants us to have fun and play with Python a lot. Kudos to the founder by name Guido van Rossum. Python is all fun and so easy. Before we get started, we need a means of writing. We have many choices of where to write. For example, we can write on a paper, on a whiteboard, or on a blackboard, etc. In programming terms, these special environments where we write our codes are called an integrated development environment, aka IDE for short, and it gives us a medium to write on. There are many of them for Python. For this class, we'll use the most popular one, ideally. Does ideally mean that we are idle and lazy? No, of course not. It is actually an acronym for Integrated Development and Learning Environments. So finally, let's install Python. So what does it mean to install Python? It is the process of getting Python from the internet into our computer so that we can use it whenever we like. Open your browser on your computer that is connected to the internet. Type www.python.org, which looks like this. Go to the download page and click on the download button. The page will guide you on the step-by-step process to download it. You will select the one meant for your computer, either it's Windows, Apple, Linux, or others. And on the page, click on the latest Python version available, which should be version 3.8. And now the installation has begun. If you're on Microsoft Edge, it will ask you what to do with Python. Just select to run. On other web browsers, you can simply just wait for the download to finish and click on it to open. You are finally done. Python is less than 30 megabytes. Python is free and you don't pay to install. Also install the ideally, the environment where you will use Python. This is the ideally now installed. It's like your Blackboard where you will type your Python codes. Now let's play around with this idle space. Let me switch and play around with it before we go back to class. So this is just an example of how ideally looks like. We're going to be playing around with it. Let's try doing some basic addition. 5 plus 5. We get 10. What about if you want to type our name? So let's put my name is Bolu. Let's see what it gives us. Wow, it was able to replicate that. Let's see. What about multiplication? We've already tried addition. Let's say 2 times 2. Unfortunately, we can't use x. If we use x in Python, it will give us an error. See, syntax error, invalid syntax. X in Python, on contrary to the regular times sign we use in class, it does not work. We have to use the asterisk, which will give us 2 times 2. And of course, it gives us 4. Let us try division. We don't have the division sign, so we use a slash, like the one we use when we are dealing with fractions, and then we divide 6 with 2, and we get 3.0, which is 3, and we are correct. Let's work with some subtraction, 8 minus 2, some basic subtraction, which will give us 6. Let's see raised to the power of 3 raised to the power of 4. Unfortunately, we can't get subscripts in Python to give our raised to the power sign. So in Python, we do star star or asterisk asterisk to raise it to the power something. So 3 asterisk asterisk 2 will give us 3 raised to the power 2, which is 9, and 3 star star 4, which we were originally looking for, would give us 81, which is 3 asterisk asterisk 4, which is 3 raised to the power 4, 81. We can also work with bigger numbers. What if we do 3 raised to the power 8, which is way larger? We should get 6,561, and of course, we're correct. Python is really getting its maths right. What about we try an even bigger number, 15 raised to the power 40? You'd expect that, like a regular human being, Python will take time to calculate this, but of course, Python is way too smart to let that happen. Instantly, Python is able to give us our answer, which we can see here on the screen. Wow, it's a very large number. What about we do long chains of multiplication, addition, subtraction, and other stuff like that? We can work with 2 multiplied by 2, multiplied by 2, multiplied by 2 again, multiplied by 1 more 2. And then let's just add 3 for the fun of it. So our answer is 35. Python must be very, very good at maths to get it instantly. What about we try using parentheses? If we do 8 raised to the power 2 plus 3 raised to the power 2 again. So we use the parenthesis sign if we want to specify that Python should do this part of math before it goes to the other side. Of course, we are following the rules of board math, which I'm sure a lot of us here already know, but Python also knows board math. That's why it will be able to give us our answer here as 73. We can also work with negative numbers in Python. If we do 9 subtracted by 100, we'll get negative 91, which is a negative number, of course. So some people have largely accused Python for not getting some questions right, which is something like this: minus 20 raised to the power 5. How is it giving you a negative number? A lot of people ask this question. Actually, what happens is they didn't specify properly enough. If you do this, Python gives you negative 32, no, 300, 3,200,000, oh, sorry, I meant 3,200,000, of course. But if you actually specify and put this inside the bracket and raise it to the power of 5, oh wait, it gives you the same question. It gives you the same answer. But a lot of people still accuse Python for this because in other cases, it doesn't always work like this. If we use 4, it would start giving us different answers. Why don't you try it out yourself and see what happens? I'm going to be waiting for you to try it out. So I give you 2 minutes to try this out yourself. Have you tried that? Of course, if you've done it right, you probably have seen that the two values it gave were not the same. So let me try it myself for all the people who weren't able to try it. If we do minus 20 raised to the power 4, we get this, we get 160,000. But if we try minus 20 raised to the power 4, it gives us negative 160,000. You see, the order of operations vary depending on where you put your brackets from. And this is what a lot of people were confused about, and they ended up accusing Python of making them fail their test. Another example of this is when we try minus 1 raised to the power 5, we get minus 1. But if we try, sorry brother, we meant if we get minus 1 raised to the power 4, because we see if we use 5, it will give us the same value. But if we try 4 and then we do this instead, it gives us -1. And we've already proved that it's just based on the order of operations. So with that being said, and having it been done that we've already played enough with our IDLE and gotten fully introduced to just the basic framework of it, let's go back to the class. Okay, so expressions and data types and variables. In this course, we'll focus on 3 beginner topics: expressions, data types, only the 3 basic ones in data types, and variables. So first of all, let's understand an expression. An expression is the most basic type of instruction in Python. It consists of values, such as numbers, and operators, such as the plus and minus sign. An expression is a combination of values, variables, operators, and call to functions. If you type an expression at the Python prompt, the interpreter evaluates it and displays the result, which is always a value. As we have seen before, Python was able to give us the answer to stuff like 3 plus 2, 4 times 4, 2 times 2, and even when we tried bigger numbers, it was still able to give us an accurate answer for it. It was able to evaluate it. So now let's try working with all the operators again. We have addition, subtraction, multiplication, division, exponents, which is raised to the power something, and in Python we've identified it to be asterisk, and parenthesis. So let's just try some basic exercises for each of them. We're going to work with 10 typical cases. You can see in each individual operator and something you can just show people around you to impress them. So we already know 5 plus 10. It's a basic math problem. Python will definitely get this because it's a very simple problem. So what about if we try working with negative numbers? So Python will be able to identify this and move the 20 to the front and move the -6 to the back so that it looks like 20 minus 6. And if everything was done right, it should give us 14. And of course, Python was 1 second correct. What if we do 6 plus -2 instead? Of course, we are all familiar with our basic math, which is plus multiplied by minus, or if you have plus and minus right beside each other, or separated with a parenthesis, plus and minus always gives you minus. So if we are correct, this should give us 4, exactly. 90 plus 2, which is adding a big number with a small number, should give us, of course, an accurate answer of 92, because Python doesn't only work with larger numbers, medium numbers, small numbers. It can deal with all numbers together. Let us try double plus signs instead. Well, being familiar with plus and minus equals minus, we should all know plus and plus equals plus. 2 positives makes an even greater positive. So 94 plus 2 should equal 94 plus 2, which is 96, if we are correct, exactly. What about 44 minus 2? So double negative makes it positive, but this is not always the case in real life, not in math. But if someone does a negative to you and do a negative back to them, it's not always the best decision. But in this case, Python and mathematics in general interpret negative and negative to be positive. So this should give us 46. So let's just go back to our basic maths, which is 19 plus 3, and that should hopefully give us 22. And let's do some more basic math. 14 plus 8. Wow, another 22. So of course, as we can see, we can have 2 different problems that give us the same answer: 19 plus 3, 14 plus 8. So it's not that Python has equations like this saved in its database. It just has an algorithm that allows it to calculate values. What about we do longer chains of plus and minus? What if we do 6 plus minus plus 3? I'll give you a few seconds to try this out yourself. Have you done it? Okay, so this should give us 9. Why, you may ask? Minus and minus is equal to plus, as we've identified before. So if this turns to a plus, that would mean plus plus plus. Plus multiplied by plus, rather. Plus multiplied by plus will give us plus. So that means this entire part would equal a plus. And this entire plus and this plus, as we've identified earlier here, is just plus. So that would be 6 plus 3, which will give us 9. Oh wait, we made an error. This is a very common error a lot of people make. So when you go back here to edit your code, you are not meant to click enter from here. It will give you a syntax error because multiple statements are found while compiling a single statement. So once it sees numbers like a basic addition, it will just consider this one statement. But once you add an enter in between it, it will give you an error. But don't worry, there are ways to actually solve and tackle the problems of working with multiple lines. But that one is later on in the course when we are talking about strings. And hopefully, if you get the AI book, you'll be able to find out in a few chapters in. But I'll really encourage you to get the AI book. It's fantastic. So if we go back here and try this, it should give us 9 if we try. Oh, and remember, Python is only able to understand basic mathematics. That's what an expression consists of 2 parts. Remember that. It must consist of the first value, the operators, and the second value. But as we can see here, we've tackled 2 common problems you would probably make while trying this out. The first problem is when is multiple statements because of all this space here. Python interprets all this gray part as part of the problem and it doesn't understand this. While in this one, this is not an expression. We have identified an expression consists of 3 parts. The first value, the operators, and the second value. But here we didn't have a second value, so it labeled it as invalid syntax. But hopefully now we should get it. Exactly, 9. What if we try an even longer chain? What if we do 6 plus plus minus minus plus minus plus minus minus plus 1? So this, with my guess, this would give us 5. But of course, I'm just a human. Python will probably say it's 7 or 5. But we don't need to think about this ourselves since we have our good old friend Python working with us. So Python should give us 5. Yes, wow, I was correct. Anyways, so you can try your own. You can even go as far as doing something like this. Just show people around you. You can make this a fun game you can play with people around you. You can tell them, try and guess this, and you will show them how smart Python is, and Python will instantly solve it before their very eyes. Who would have guessed that all of this would equal to plus? Surely not me. Anyways, now that I think we've mastered how addition looks like in the Python framework, let's move on to subtraction, the minus sign. Of course, we've identified earlier in this course that Python is able to understand negative numbers, which is numbers behind 0 towards the left in the number line. So 5 minus 10 should give us -5, and of course, Python got that. What about if we had 2 negatives, as in -6 minus -20? Python again is still able to solve these problems. What about negatives? What about 3 negatives instead? -6, -2. So now we have 3 negatives in our problem. So what do we expect Python to do? Do you think Python would just give up or throw a tantrum and start saying error? Of course not. Python should be able to understand that this is positive and -6 plus 2 gives us -4. But of course, Python is a genius, a whiz kid in mathematics like me, and I assume Python should be able to get it, of course, -4. 2 subtracted by 90 is another case of working with small number and big number. Python, as I mentioned earlier, can work with big numbers, small numbers, medium numbers, long chain numbers, everything simultaneously. So this should not be a problem for Python, and it gives us -88. What about working with long chains of negatives? So this, of course, just at a simple glance, you cannot get what this is equals to. But of course, we have our good old friend Python, which should be able to solve this instantly. Wow, this was plus. I really thought it was minus, but oh well, Python is always an amazing mathematician. So let's move a bit into multiplication. Or before I get into multiplication, let's quickly review one more thing about subtraction. Did you know it is possible to put the smaller number, then you can put another number, and then you can put another number and more numbers and more numbers and more numbers. Why? This and Python is still able to give you an answer. This instantly. This is because Python is able to deal with long chains, not only long chains of operators, but long chains of operators simultaneously working with values. So you can put long chains of values. And if you still want to work with even bigger numbers like this one, Python should still be able to get you an answer. So with that being said, let's jump right into multiplication. Multiplication, I'm sure a lot of us are familiar with our times table: 2 times 2, 4, 4 times 4, 16, and all the rest of them. So Python does not work with X. Python cannot deal with X, as I mentioned earlier at the start of this course. It will just give you an error. That is why, because X works as the letter X in Python and can also be saved as a variable, which we'll also treat later in this course. So instead of that, Python has replaced it with the asterisk sign, which a few of us should be familiar with by now, considering we've been using it quite a while if you started the course from the beginning of the class. So 5 multiplied by 10s, and of course, everyone here should be a whiz-kid and be able to understand that 5 multiplied by 10 is 50. Because 5, we can separate this to 5 multiplied by 1, that would be 5. And then we just add the 0 behind it, and that's 50. That's a really good shortcut to solving math questions like these. What about working with negatives and using multiplication? This should be -120, and of course Python will get that easily. -6 multiplied by -2. We already know Python knows what to do with minus times minus. That's plus. 6 multiplied by 2 is 12. So we should be expecting plus 12, but of course Python won't show us the plus 12. It will just give us a value which should be 12. And of course, Python was correct. So working with small number and big number again, 2 times 90, small number 2, larger number 90, bigger 180. We can also work, what about trying mathematics that you won't even be able to guess? If I gave you 172 times 28 to solve instantly, would you be able to solve this in your head? Well, some of you may probably be able to do it, but there's only a very low chance you get it correctly. But Python, being a genius, just instantly. Try adding your own questions to Python. Try using larger numbers, and I'll give you a few seconds to try that out. Okay, can you see that Python was able to act as a calculator in that case? So basically, Python can do a lot, as we've seen so far. So let's move into division. Of course, division is represented by this sign. Python does not have the division sign or does not understand it, and we don't even have it on our keyboard. If you look around, you can't find the real division sign. So we work with the sign we use when we're working with fractions and other questions like that, mixed numbers. So if we want to divide something like 6 divided by 2, we use this sign instead. And hopefully Python give us 3. And of course, what about if we do 2 divided by 6? This one, as we all know, should give us 0.33333. So Python only shows us a few of the decimal places because this one, it goes on forever. But let's try and count and see how many decimal places Python gives our non-integer values or non-whole number values to be. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16 values back. Do you think you can remember all 16 values back when you're solving math problems that have even longer chains? Like even pi, which is 3.1415926, and these are just a few of the numbers. Do you think you can remember 16 numbers back? Of course not. But Python, being an absolute genius, maybe the best of its time that we have right now, Python is amazing. That's all I can say in summary. We can also try using negative numbers in division, which we can try as negative 81 divided by negative 9. Of course, this would be 9 because negative over negative cancels each other. These are some other basic rules you can use. Negative over positive is negative. Positive over negative is negative. Negative negative is positive, and positive positive is positive. So time to fully move into exponents. So as we can see, there's a difference between the asterisk and the double asterisk. We've used the asterisk multiple times to signify that we are doing multiplication. And now we're going to be working with the double asterisk, which is our raised to the power sign, as I've indicated earlier. So if we want to do 6 raised to the power 2, we would use double asterisk, then 2, and then boom, we get 36. Python is really on fire. What if we want to try an even greater number? What about 6 raised to the power 100? Of course, Python still pulls through and gets this right. You can also try doing this on your own calculator, and see what values it gives you. But most calculators, even the scientific ones, only give us up to 50 places and estimates the rest to be 0. So don't you think Python is even better than the capabilities of your own handheld calculator? Python can also work with raising numbers to decimals. Like let's say 0.5. 0.5 is half, and anything raised to the power half is root of that thing, as we have seen in basic mathematics. And if you have not gotten there yet, just ask an adult to explain indices to you. 64 raised to the power half is root 64, which is what number multiplied by that same number would give you 64. And being geniuses here, we should know that 64 raised to the power half is 8. And perfect. Python gets this exactly. And what if we do 9 raised to the power -4? Of course, none of us would have guessed this answer ourselves, but Python still pulls through and helps us solve some amazing mathematics. We can also try using Python with parentheses. parentheses. So assuming we can't sum it at 0.5, like let's say we have 0.3, and since this is a recurring decimal, we'll continually have 3, 3, 3, 3 repeated. What if we try doing this over 6? Can Python still work with this? Of course. Python understands the basic operating rules and of course gives us 2. And that makes sense because 8 raised to the power 1 over 3 is 2. 2 multiplied by 2 is 4, and 4 multiplied by 2 again is 8. With that being said, let's jump right into the last part that we'll use to end our talk on expressions. We're going to work with parentheses. What if we try some basic broad math logic and do something like this? Do you think Python would still work in a question like this? Of course, Python will do 3. Of course, we don't have a multiplication sign here. We don't have to. Python can do it for us. And 3 multiplied by 8 should give us 24. Oh, wait. Of course, silly me. I forgot something. Python cannot solve your math for you. It wants you to work hard and do it yourself when it comes to more advanced problems. So we can do this little cheat thing and take that away from Python and do the asterisk. Of course, there are other ways we can actually use this real one in some other programming languages, but Python does not do this because it supports you working hard to get your answer, which should be 24. What about, we are now combining a lot of stuff we've learned together, and we try 5 plus plus minus minus plus minus plus plus minus minus plus minus plus. And then after doing all of this, let's put 4 here, and let's raise it to the power of something like negative 17. You'd think Python would just crumble under the weight of a question like this, but of course not. Python still pulls through and gives us an answer. So with that being said, let us move back to the class. So 2 plus 3 is an example of an expression in Python. It's the basic instruction which consists of values, the number 2 and the number 3, as we can see here, 2 and 3, and an operator, the plus sign. Some examples of operators like we used before are the plus, negative, multiplication sign, the division, the exponential signs, which is double asterisk in Python, or raised to the power in regular mathematics, and parentheses signs. The expression evaluates to a single value, 5, when you hit the enter button on your keyboard, as we have seen before. These are some exercises on, some more exercises on expressions. But seeing that we've done a lot on expressions, how about we take this up a notch and start trying real life problems with these. So let's open our ideally. So what if instead of working with just regular numbers, let's say we want to actually solve a problem. Let's say we want to calculate how many seconds are in a decade. Wow, isn't that a lot? Of course, we cannot calculate this in our head. We have to work this out ourselves. So Python can do 60, that because we have 60 seconds in a minute. So we multiply that by another 60. But we have 60 minutes in an hour. So we put 60 here. Then we have 24 hours in a day. So we put 24. Then in a day, we have 365 days in a year. But we're working with a decade, which is 10 years. So we added another 10. So this is second, minute, hour, day, and decade. So let's see. That means in 10 years, you can go and tell, wait, no. Oh, of course, Python is definitely correct. So you can go and tell people around you that, you have 31,536,000 seconds in just that short amount of time. So go and surprise people around you. You can tell your parents, you can tell your friends, you can impress them with your amazing math skills. So let's look at another problem. Since we've already tackled the time problem, what if we want to find the average of people? In mathematics, the average is the sum of the individual values divided by the number of values. Let me break this down for you. If we have 10 people, and their ages are as varies, we do 10 plus 9 plus 8 plus 7 plus 4 plus 12 plus 11 plus 15. So let's say we had these many people in the class. But let's add an extra 2 to make it 10 so that we can get an even better answer. Let's say we have someone who's 12 and then we have someone who's 13. So to get the average of a number, we sum all of these numbers together and then we divide it by the number of numbers that we have here, which in our case should be 10. And that means the average would be 10.1. And can't you see, 10.1 is within the range of these numbers. That means Python must be very brilliant to even help us calculate averages. But what if you want to make the problems more personal? What if you want to calculate your age? So this age one, it actually depends on you. So we are going to first start with, we will do 2020 subtracted by the year you were born. I don't know what year you were born, but I was born in 2005. So 2005. But there's a catch to this. Whatever you get, let's say you got 15 or whatever number you got. If you have celebrated your birthday this year, you leave the number like that. But if you haven't celebrated your birthday that year, you subtract it by 1. And I haven't celebrated my birthday yet. So I have to subtract by 1. And thus, exactly, I am 14 years old. But what if we want to find out how many days we've spent in that 14 years? So we know we have roughly 365 days per year. So let's try multiplying that by 14 to get a rough estimate. Wow, 5,110 days already gone. That is such an amazing work Python has just done for us. So with that being said, let's move on to the class as we finally round up this exercise on expressions. Let us move into data types. What are data types? A data type is a category of values. Every value belongs to one data type. The 3 main data types are integers, floating numbers, and strings. Integers are positive or negative whole numbers such as 0, 2, 20, 1003, negative 600, etc. Integers can be shortened in Python as ints. However, floating point numbers are numbers with decimals. Example, 1.0, 12.3, or 0.7364. In Python, they are just called floats. While text values can also be called strings. What is a text value, you may ask? A text value, for example, like a word, Nigeria, and the phrase, I ate 3 loaves of bread, are both strings. They are not numbers like integers or floating points. When typing strings, we begin and end strings with single or double quotation marks so that Python knows where the text begins or ends. But this still does not answer our question. We still want to know What is a text value? Don't worry, I'll answer you in a second. Strings can be described as a collection of keyboard characters and symbols enclosed within quotation marks or double quotation marks. We have single and double quotation marks. If you wanted to print a sentence with an apostrophe or quotation mark in it, you use the double at the start and end of the sentence, and within it, you can use a single. You can use triple of any if you want to write in multiple lines. So, wow, this calls for an activity to really test if we understand what we've just read. So what we've just read is a string, is a collection of characters enclosed with these signs, which is apostrophe signs. You can use the single, we'll try the double and the single and the triple. So first we try the double, it works. What about we try the single rather? It also still works. What if we try triple of both? Still looking good. What if we do triple single? And still works. So you can use any of these three depending on what you want to do. But there are two here that I've done that are actually special cases. You can use the triples when you actually want to write over multiple lines. Let me give you an example. If you want to write an essay to your friend, you put, hello, my name is Bolu, and how are you doing today? I am 14 years old. There today. Let's say it's your birthday. So with this one, you can write over a series of lines. But if you use just the regular one and you put hello and put an enter, of course, EOL will give, this is an error where you either don't finish or you wanted to finish on a different line. Of course, it will not allow you. Another trick we've seen here is, in our lesson, did you know there's a way to convert an integer to a string? Of course, you probably didn't know. A way to do this is you can actually just put like a number enclosed inside an apostrophe. So let's try this out ourselves. If we do 5 plus 5 normally, we'll get 10. 2 plus 2, we get 4. Python still understands basic math. But the second we put these numbers in between the apostrophe signs, it gives us that exact same number. By each individual character is no longer something to solve for, but it's now become just a piece of text. It's like the same way you say hello, there's nothing to solve for hello. So that's how it is like. We can also work with something called type. Type is what allows you to find what type of data you're working with. So we're just discovering some shortcuts that you can use later on in the lesson when I give you some activities to work with. So if you want to find the type of a verb, type of anything in Python, just put it in between these brackets. So if it's a text, you want to be like hello, it tells you it's a string. What about you try this one? It will tell you it's an integer. And if you try this, 1.1, should give you floats, exactly. So now, that being said, let's continue on into the lesson. But before we do this, just to make sure that you fully understand this, try doing this yourself. Use the triple apostrophes and write this. Write your name, mine is Bolu. Type enter, write your age, but mine is 14. Then now put your gender, I'm a male. And then put your class. I'm in year 10, but some people prefer to call it as SS1, so I'll just put year 10. or SS1, and then I can put 1, 2, 3, and it will give me this. Why didn't he give me over a series of lines, you may ask? This sign actually represents this entire line. So Python is still able to work with this. But assuming what to use a single, it gives you an error, like we have seen earlier on in the class where he gave us an EOL error here. So now I'll give you a few seconds to try this out yourselves. Try seeing if you can work with this and try getting that error yourself and see if there are ways to prevent the error. Okay, I'm assuming you all are done, and I'll be continuing on with the class. So let us do an exercise from the AI for Beginners book. We want to sort the data into their type. It is like sorting our toys into their groups or our apps into their folders. We all do it so well. So let's do this in 5 minutes. But don't worry, if you don't remember what an integer, a floating point number, and a string is, I'll be explaining as we do this activity. An integer, don't forget, is a whole number. So it's any number that does not have a decimal point behind it. Floating point numbers have decimals, and the decimals can range from being like 1.0 all the way to 0.333333, 0.555, 0.76214, while strings are just basically pieces of text that's enclosed by apostrophes. So remember, string is pieces of text enclosed with apostrophe signs, either single or double. Floating point numbers have decimals behind them. Integers are just whole numbers, either negative, positive, they still work. So I'll just give you have 3 moments to solve the problem and arrange it. You can Right now, you can type your answer in the chat section or comments, and let's keep trying to solve this problem. So you can send this and discuss with fellow people in the chat to see and compare your answers if you got it right. But of course, I'll still explain and show you the answers. But it's always good to work with other people. But of course, don't cheat. 2 more minutes. Just a gentle reminder, you can get the AI book if you still want to purchase the full book. What we're doing with this course is just a small segment of the bigger picture. You can purchase the AI book from Amazon, Google Books or Play Store. You can get it on Jumia, but don't worry if you've forgotten the link or you didn't take it down the first time and you're reconsidering and to getting the book. You can, don't worry. At the end of this course, I'll give you the links to get the book. But just know that book is amazing. I've read it myself personally. It's just fantastic. We have 1 more minute. You can start rounding up your work, but just one more reminder. Strings is apostrophe. Just something you can use to remember it is. Strings is apostrophe. Floating point numbers has decimals. Integers is whole number. It can be positive or negative. So a few more seconds to go. So a few more seconds to go. So we have a few more seconds, and we're going to be doing this in a few more seconds. And Yes, now. So these are the solutions for the activity we just did. So under integers, we have 1 minus 652 and 78. Why is minus 652 under this, you may ask? Well, we discussed earlier that integers can be both positive and negative, big number or small number. So 1 minus 652 and 78 perfectly fit under the description of an integer. Floating point numbers are any number that has decimal points. It might have decimal points both it might have decimal points all the way to 10 digits back, or even just 1 digit. As you can see here, that's what separates this one from the 1.0. Though they're the same value, the fact that this one has 1.0, it means it's a floating point number. You can see here in more bogus problems where you have 0.11111 reoccurring. This one is definitely a floating point number because it has numbers behind the decimal point, and this one likewise the same. And of course, I'm sure almost everyone would have gotten strings, because strings are the easiest one to remember. It's just if you see this sign or this sign, instantly know it's a string. So Peter, apples, decimals, numbers, those are the ones under strings. Now let us move on to variables. Variables are where we store stuff in Python. A variable is like a box that stores a value that may change. As we can see here, the name of the first box is x, and it contains 1, meaning we can equate x to 1, and likewise y to 2 and z to 3. Let's try this out ourselves, and let's see what we can do with this. I'm thinking, what if we make a code that allows us to know which number or the placement of a letter in the alphabet? To do this, we'll have to first represent each letter as a number. So A is equal to the first one, B is equal to 2, C is equal to 3, D is equal to 4, E is equal to 5, F is equal to 6, G is equal to 7, H is equal to 8, I is equal to 9, J is equal to 10, K is equal to 11, L is equal to 12, M is equal to 13, N is equal to 14, O is equal to 15, P is equal to 16, Q is equal to 17, R is equal to 18, S is equal to 19, T is equal to 20, U is equal to 21, V is equal to 22, W is equal to 23, X is equal to 24, Y is equal to 25, and Z is equal to 26. I'll give you 5 minutes to try and complete this because I might have gone a bit too fast. So you can just follow up. I'll just give you a few minutes to finish up with this. So I'll just scroll through mine to show you. A1, B2, C3, D4, E5, F6, G7, H8, I9, J10, K11, L12, M13, N14, O15, P16, Q17, R18, S19, T20, U21, V22, W23, X24, Y25, Z26. Okay, you have a few more seconds to finish this up. So I'll just do a small countdown starting from 30 down. 30, 29, 28, 27, 26, 25, 24, 23, 22, 21, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. So now let us try this. So we all know A is the first letter in the alphabet. So if we put A, it gives us 1. What about we want to know what position L is? It gives us 12 instantly. And if it doesn't give you 12, try and see if you made a mistake while counting. You might have assigned L to the wrong value. So now, just T, 20. So you can do a fun game with your family where what you do is you ask them to guess what letter, is the number. So, or what number is the letter. Yeah, that's more accurate. One number is the letter. So you just give them a random letter from the alphabet, fresh from your head. Let's say X, and then they try and guess it. And you can cover like the part where you coded, and they guess where it's from, what number it is. You type it on Python, and Python gives you the answer so that you can validate it. So if it's like, okay, let's say I'm playing with my friend. My friend asks me what position is let's say H, and he closes my eyes and I'm meant to guess it, and then if I guess something like 8 and then he shows me it's 8, oh wow, I got it, perfect. So now that so what we did here was actually assigning with variables. In assigning in variables, you basically just give something a value. It's like putting something into a box, as we saw earlier. So these are like containers that only take one thing and one thing alone. So you can put it inside. So now let's try working with this. What if we do A plus B plus C plus D plus E plus F plus G plus H plus I plus J plus K plus L plus M plus N plus O plus P plus Q plus R plus S plus T plus U plus V plus W plus X plus Y plus Z. So it's meant to give you 351. Try this out yourselves. So you can try this. I'll give you just a few seconds to attempt it. Or let me just finish a series of activities and you try it. I'll give you 5 minutes to do all the activities. So follow after me. I'm going to be doing. What about we do this instead, but instead of plus, we do multiplication. So we do X times B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, X, Y, Z. So be careful that you don't make any mistakes. You should get a number as big as this. And if we try 1 times 1 times 2 times 3 times 4 times 5 all the way to 26, we should get this exact same number considering they are being represented by the same. And lastly, we'll add A all the way to B, all the way to Y rather. Instead of doing what we did last time, we put a closing bracket at y, and then we divide everything by z. Let's see what it gives us. Over, we just put over z, and wow, would you have guessed that all the letters in the alphabet added together except z, and you divide it by z, it gives you 12.5. So that's a cool trick. You can go to your friends, you can brag about it, you can tell them, did you know if you that's how powerful z is compared to all the other letters. If you add everything together and divide it by just z, you get 12.5. So I'll give you a few more minutes to try out these activities. In that time, if you finished it, you can also try your own activities, try messing around, try A plus C plus E plus G plus I plus K. You can skip letters, you can mix letters, merge letters, just have fun with it, play around with it, understanding. You can also show people around you that, oh, wow, did you know I did this? I made this. So it sort of looks like mathematics, but we are just understanding the principles of programming. You can also play around with the game on what A is. Like you can still do this B and it will still give you the real value. If you still want to see what I did earlier, I'll still scroll back to show you. This is it. These are 3 activities that you'll need to try. I've highlighted them from here to here. So this is it. So you can try them out and I'll wait for you for a few minutes. Okay. Okay. So far, this is how your ideally should look. A few errors here and there, but don't worry, those errors were deliberate, they were intentional, so that you can prove some arguments a lot of people make about Python. So remember here, always be hardworking. Don't try and cheat and skip the star. Don't try and jump steps. And that's what it takes to be a programmer. Don't jump steps, follow instructions. We've learned all about strings. We've learned how strings all have to do with the apostrophe, and that if you want to do several line sentences, you use the triple. We've worked with some expressions, some numbers. We learned how to find the type of something. See, we have the string, the integer, the float. We've learned about basic maths in Python. We've learned how to make a game that you can play with your friends on how to guess the number from the letter. And we've played around with some numbers. So let's continue a bit more into this course. Oh, wait. Oh, never mind. Let's continue back into the course. We'll do the next activity later on in the course when we have a better understanding. So these are some basic variables that we use here, as we can see. Some basic variables. We've done stuff way more than this, so we can just continue. You can try these on your own. I'll give you a few minutes to try these. Type x plus y plus z. Don't worry about getting 12 and 14. We use separate numbers because we wanted to make a game, but hopefully it should look like this. It doesn't have to give you these numbers because we use different values from them. So x plus y plus z, just put that in. X multiplied by y, x plus y divided by z, x is equal to 11x. Okay, so we're going to try that ourselves. So if you do x plus y plus z, you should get 75x multiplied by y. But what if you want to change a variable? Just what if you wanted to remove what was inside that variable and change it, like make it something else. So we can see here f is equal to 6, of course. What if we wanted to make f equal to 16 instead? So that's easy. You just put f is equal to 16, and if we put f now, f is now equal to 16. No matter how many times you try, f will keep giving you 16. If you want to change it back to 6, you just do f is equal to 6. So this is what you call reassignment of variables. So it's like removing what is inside the box, putting something else in the box, and then if you don't want what's in the box now, you move what's in the box now, take it out, and put what was in the box before, you can put it back, or you can put something entirely different inside the box. We're still also going to learn a few more tricks on deleting variables and other stuff like that, but don't worry, we are still going to get into it. So let's continue back into the class. So now there are some rules of naming variables. So the first big rule you must remember in naming a variable is that the variable can only begin with the letter capital A to capital Z or small e to small z or an underscore. It cannot start with a number, cannot start with you cannot start with numbers, you cannot start with integers, floats, or anything like that. Or you can't even start with an apostrophe or a comma. It has to start with either a letter or an underscore. And Python is very case sensitive. So if in one part you use a capital letter and you want to call the function later, you cannot do that if you don't put it in capital letter again. But don't worry, I'm going to show you all of these. I'm going to show you the practical aspects of them. So let's go back to ideally. So as we said, you can only start with either an underscore, or sorry, of course you have to assign a variable, we all know that. So this arrow is just showing that you need to assign it to a variable. Once you see it's not defined, just know you've either not assigned it to anything or you just made a typing error. So you can go, so if you ever see this error later on, you can always just know, oh, let me just check if I did this, if I did that. So let's see, my name is equal to, I'm going to demonstrate several things at once. So let's put name is equal to Bolu. It works. So if we put underscore name, it gives us Bolu, perfect. If we put name, regular name, is equal to, pay attention, serious attention. I'm going to be explaining multiple things at once. So if our name is Bolu and we call name, it works. If we put n underscore a underscore m underscore e is equal to Bolu, and put n underscore a underscore m underscore e, it gives us Bolu, perfect, it works. My underscore name is equal to Bolu, works. Pay close attention now. If we put my underscore name, gives us Bolu. But in Python, you cannot put a space when putting a variable. You cannot leave this space. It would throw its tantrum and say, no, you cannot. It's wrong, because it can only understand variables when they have an underscore in between them. So if we try this one, hopefully, if we are right, it should give us an error. And of course, it gives us an error, invalid syntax. It would actually take the my as Bolu, but it will not take the name. But because of the invalid syntax from the name we've added, it will give us an error. And pay close attention, I'm still explaining more things. If it now puts something like its name is equal to Bolu, of course, we've learned you cannot start with a number. And there are also some assigned names. So in Python, we have some assigned like for, if, else, cannot change these ones. These, you see, they already becoming colors, so that once you're typing them, you know, oh wait, they already have something attached to them. Even elif, they all have something attached to them. You cannot assign print to do something else because see its purpose, part of the Python configuration. Another thing I've mentioned earlier is how you have to keep it in the same case. So if you say Bolu is equal to 14 and you type Bolu, it will give you 14. That's because I put these in capital letter. But assuming I now put it in small letter, it will say name Bolu is not defined. Why? Isn't it the same Bolu put here? No, it's not. This one was in small letters. This one was in capital letters. So if we now try Bolu, it will work. But now, if we assign Bolu to now be 14, and we type Bolu now, Bolu should work since we've now assigned Bolu to something. Because before I said Bolu was not defined. Another thing we need to remember is that in Python, you cannot, and I cannot stress this enough, a lot of people make this mistake. You cannot start with what you want to name, like let's say Bolu, and you cannot name it. You cannot do Bolu is equal to X. No, it says you cannot assign to literal. It has to be the other way around. It has to be the other way around. You cannot switch them. They are not interchangeable for each other. So now let's look at a couple more tricks that can be useful. Okay, so let's say we have A to be 1 and B to be 2. What if we wanted to make A 2 and B 1? What if we wanted to switch their values? Of course, we could do that manually and waste time and even leave room for errors. Or we could do this the smart and faster way. We could do what I like to call the switching trick, which is A comma B is equal to B comma A. So what it does is it picks this A separately from this B and picks this B separately with this A. So it's like putting A equals B, and while A is equal to B, before the value of B is changed to A, before the value of A is changed to B, you now do B is equal to A. So these two will do it at the same time before they change their values. So it's like trade of butter, but we are doing it at the same time. Let's say I want to trade rice for yam. As I'm giving you the rice, you are giving me the yam. So we both have it at the same length from each other. So the second I give you one, you give me the other, the exact same second, and that's what this trick does. So if we try this now, A should give us 2 and B equals 1. I mean, if you want to switch it back, this is also interchangeable. You can do B is equal to A is equal to B. This is the only thing that is interchangeable because it's two variables on both sides. So you can change it back, and A should give you 1 and B should give you 2 again. You can also use this trick for when you're assigning long chains of variables. So this another way we could have done our A, B, C, D thing is if we did A, comma B, comma C, comma D, comma E, we now said is equal to 1, 2, 3, 4, 5. It just assigns it. Or since we already have it as these values, let's make it something else. Let's say A, B, C is equal to 3, 2, 1. So A should be B, no, A should be 3, B should be 2, C should be 1 now. So A is 3, B is 2, C is 1. Now we can see the value has also changed. And as you can see, you can also make the same thing, the same value, the same way we did Bolu here was 14, capital Bolu was 14, that small Bolu was 14, underscore name was equal to Bolu, name was equal to Bolu, N underscore A underscore M underscore E was equal to Bolu. You can all say them to the same, you can put the same thing in each of the boxes. Or an even faster way to do it is if you want to make several things the same. So let's make A, B, C, D, and E the same. You can do this. If you want to make those letters I put the same, you do A is equal to B, which is equal to C, which is equal to D, which is equal to E, and now assign it to your value, which should be A. So if you now put, which should be 5, if you now put this, they will all equal to 5. But of course, if you put F, it will give you something else because we didn't assign F to any changing one. So the last thing we are going to talk about in variables is deleting a variable. What if you don't want the box again? You want to throw away the box that is containing the value. You just don't need it again. Let's say it's taking up space, you don't like it anymore, you are not using it again, or something like that. You can just do del, which is another, what I call a sacred word. Once it has a color, you cannot assign it. If you do del, let me just quickly show you something. If you do del is equal to 3, invalid syntax, you cannot change it, you cannot assign this to anything. So anyways, you can do del, let's say a. Now if you put a, it should give you an error because we have not defined a anymore. But if we do b and we do del b, if we now do b again, it will give us an error. So let's go back to the class and round up. So everything here, we've already talked about it, swapping variables, deleting variables. We've already tried this. You can try it a bit more. You can work with it. And this is just a small activity you can do. You can take it at home. You can post it in the chat if you are fast enough. You can take a screenshot, send it to me at adekanmbi13@gmail.com. Let me just quickly show it to you. adekanmb@gmail.com. You can send it to me, and you don't have to send it to me. It's just so that I know that, okay, you are fully mastered this and you can do it on your own. So this is my email if you want to send it, and you can also tweet it if you have a social media account, or you can send it to Data Science Nigeria that, oh, I now understand this and I understand that, and so on and so forth. So before I go, just remember to get a copy of the AI for Beginners book from Jumia or Amazon. All activities in this work was taken from the AI book for Beginners. And wow, this book is amazing. I cannot stress how amazing it is. So these are some of the links. You can go to any of these links if you want to get the book. Amazon Kindle if you want to read it on your phone, on your tablet, on your laptop, stuff like that, on your iPad, whatever. Amazon paperback if you want the real copy, but let's say Amazon delivers to your place, because Jumia is Nigerian based. If you are not in Nigeria, you can get it on Amazon paperback. Apple iBook, also another way of getting it, the soft copy online version. Google Play Store, you can get it just to like have on your phone if you're going around. You can also share this. You can tell your friends, tell your parents if you really want to go further in this. But just remember, what we've done so far is just like the tip of the iceberg. You could, by the time you start with the book, you will learn about image classification, how to turn your writing. Like if you write, let's say on a sheet of paper, the computer will be able to interpret it to something that you've typed. And if you go even more advanced, hopefully you'll get to a stage where you will even be able to program your own self-driving car for yourself, saving costs. You don't have to buy a self-driving car in the future. You can also make tasks automated. Let's say they want you to help cook food. You can also create an algorithm that even cooks the food for you. And you can do so many different things with it. And if you want to contact Data Science, these are some of their profiles you can follow Data Science, which is DSN, on Twitter, Facebook, Instagram, LinkedIn, just to know more about their free classes, summer school, boot camps. Their website, emails, and phones are also provided. And yes, thanks for having me. Stay safe, maintain good hygiene, and practice a lot of coding and reading during this stay at home. Bye bye for now.